All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are just going to be doing some reading work. I was considering whether I want to continue with our studies of the Tokyo runtime, but then prior to the stream, I was having a conversation with Gemini about something. I'm gonna actually post that something. Where should I post it? Okay, first things first, we can export this conversation just so I can open up the thing as a markdown file on stream. Actually, how much of this conversation am I comfortable with showing on stream? Because I started this conversation talking about storage. Okay, I started the conversation talking about storage. There's a bunch that I have to read here. So earlier I was doing research on Rust and web applications. And generally, the way to go about doing that would be to use WASM. So your Rust code gets compiled to a WASM module, and then the WASM module runs in a WASM runtime in the browser, and then it is interacting with the browser APIs through, I believe, through JavaScript, because WASM isn't like directly talking to the browser. I still have to do like proper research on how this whole technology works because I haven't fully understood it. But that's kind of where this conversation comes in. Like it gives a bunch of good information. I have two reasons actually why I want to learn about Rust and three actually. One of them is just pure curiosity because I want to learn. I want to understand how it works. Give me a second. Let me just mute that. Okay, yeah. One of the reasons is just pure curiosity because I want to learn how it works. Another reason is game dev because I want to learn how to go about exporting a Rust game for the web. So if I wanted to use something like WebGL or even WASM, I need to see if the two are actually connected or if one uses the other or if they're two just completely separate technologies and you can pick whichever specific one you want. Yeah, I wanted to learn how to, go about setting things up if I wanted to export a Rust game for the web, for the browser specifically. And the third reason is in case if I wanted to make any kind of Rust based web application, which is also something that I'm interested in looking into because there seems to be quite a lot that you can do once you introduce WASM, once you bring WASM into the mix. Actually, this reminds me there is something that I would like to have a conversation with Gemini about. Let's open up Gemini here. Hopefully this doesn't take too long. But yeah, in the meantime, while that's exporting, I will export this conversation. So yeah, okay, like I was saying, in between this conversation. So yesterday I did a small gaming stream, which by the way, I was really close to doing, I was considering doing a gaming stream today as well. But the reason I didn't is because on Windows, for some reason, it's saying that there have been some hardware changes, and so I need to restart the system. And in my case, because of how wonky my system is right now, restarting is it could mess things up for me. Like it's not a sure thing that the stable state that my system is in right now, if I restart, is it going to come back with that stable state? Or am I going to end up having to restart a couple more times before it becomes stable again? Besides, I have a couple of other things that are open. which I didn't want to close. I didn't want to have to reopen them and reset everything up. Um, so it just wasn't worth it. All of that, by the way, it was for the Xbox controller. Like I'm talking about that whole hardware changes thing. All of a sudden, yesterday the controller wasn't being recognized anymore. Actually, no, the receiver was being recognized, but for some reason the controller wasn't it wasn't connecting to the receiver when um, any any gamepad supported game was started up. Then the controller wasn't really responding. um I think the only way is to restart the machine. And this dude, this kind of sucks. This is something that I don't really like about Windows. There are a bunch of situations where Windows will tell you, hey, so and so change has occurred, you need to restart. And I'm like, dude, what? Like, what about, so what if you have like long running applications? What if you have like a bunch of different applications that you have running that take some time to set up? You made a small change here and all of a sudden you have to restart the system. I have very few situations on Linux where I have to reboot the entire system. Like, I can't imagine having to do that because that would be a nightmare for me. There are a bunch of things that, like, once I start up the system, there's a couple of other things that I have to start up, and they're all part of like my workflow and part of my setup. There's a bunch of different things, and this includes like opening up the Kitty terminal, and within the Kitty terminal, there's a bunch of tabs that I have to open. Within those tabs, there have to be a bunch of different programs that I open up, stuff like BTOP, and there's a specific NeoVim instance. There's Yahtzee, the file manager. There's there's a bunch of things. Oh, Hacker Mind Map. That's another one that I have open. But yeah. Oh, also another thing that I'm kind of looking into, but I'm not entirely sure if I'm gonna use it. I'm not entirely sure if I'm gonna actually do that. Um, that is, what was I saying? Yeah, I found out that actually I kind of knew this already, or maybe I didn't know it. Maybe I was, well. Okay, anyways, I was looking at the Ratatouille website. I was looking at the docs specifically, and in the docs, one of the sections talks about like web development stuff, and that goes into crates that help you export uh, export a Ratatouille application for the web. And so they also gave a couple of examples of websites that do run Ratatouille applications. Generally, it would be one web page with the entire Ratatouille app running. It's not like an entire website with multiple pages. I mean, there could be website. Actually, there are websites with multiple pages, but generally the Ratatouille application it's one page, and everything else that's going on is going on within that page. So I was exploring a bunch of different Ratatouille apps, and um, I don't know if I want to use Ratatouille for web related stuff. As great as the concept of having a TUI application on the web sounds, and as great as it runs in a bunch of cases, something that I noticed is that the key maps can collide sometimes. So, for example, if you're ever in a situation where you have to hit the tab key to do something, maybe shift focus to a different control or something within your Ratatouille application, if that application is running in the browser and you hit tab, the the focus might actually go to one of the browser components. It might start selecting other browser components. And this is just one example of multiple other like key map conflicts that can occur. So I'm not entirely sure if I wanna set up a Ratatouille web application, or I could set up. a Ratatouille web application and explicitly make sure that the key maps that I'm using, they don't collide with any browser key maps. But then I can only do that for Firefox. I can't do that for just a second. Just a second. My God, will this mouse start working? Holy shit! Finally, I need to change the battery on this thing, dude. Yeah. Now, what was I saying? Yeah, I was saying that, okay, even if I did test it out, I'm not going to be testing it out on all browsers. I'm only going to be testing it out on the browser that I use, which is basically only Firefox. I mean, I have Opera installed, I have Brave installed, but I rarely use them. They're for like specific situations. Brave would be for like if there's a website that for whatever reason I'm not able to access through the regular web, if the website is like blocked or something. Also, if it's a website that just has a shitload of ads for some reason, then I can use Brave to like block a bunch of those ads and then view the page. And Opera was specifically, I'm not even kidding about this. It was specifically for situations where websites didn't offer a dark mode setting. It was literally only for that. I had no other use for Opera. I had literally no other use for Opera. That was the only reason why I ever installed Opera. And I guess now I haven't touched Opera in like months. I haven't opened that browser in months. Anyways, oh, you know what? I think the uh wait, I think that Gemini instance has opened up. Let me export this to Gemini explains Rust WASM Nano .md. Rust WASM Nano Glue. So this is the interesting thing. This is, I don't know if I mentioned this, but the glue crate got brought up by Gemini itself yesterday when I was doing research on. So okay, after ending the stream, in fact, towards the end of the stream, I think I'd got this doubt. I was like, okay, how would you go about saving data? Like, what kind of APIs are available for writing to any sort of local storage? So I started by doing research on that. And through that, I found out that, okay, there's this crate called Glue that you can use to build Rust and WASM applications. And I was confused about this because when I'd had a conversation with Gemini about, doing game dev stuff in Rust and exporting to a web build, it never really mentioned Glue. It mentioned the WASM bind gen crate that you can use, which provides you with like bindings for WebSys, which gives you like browser APIs and stuff. Um, but it never mentioned Glue. And so then when it mentioned Glue for this local storage thing, my God, Filian, can you control the volume of your... All right, okay. Right. What was I saying? Shit. What was I saying? Dude, okay, I've got somebody else's stream on running on another machine just so I have some background sound. It happens to be Filian's stream right now, and she's doing a scrolling 100 TikTok videos thing, and the volume is just all over the place with the various clips. Some of the clips, they come blasting through in terms of audio, like 10 times louder than her own volume. And so that then it suddenly shows up, you know. So that's why I was like, holy shit. Okay, what was I saying? Yeah. Uh yeah, Gemini brought up the glue crate. And so I was like, okay, tell me more about glue, cuz like we haven't spoken about this before. Previously you mentioned WASM bind gen. Um and so I have no idea what glue does. It turns out glue provides you a more Rust-like way of doing things with the WebSys crate, whereas WASM bindgen or whatever other crate I was planning on using in order to be able to interact with like the browser APIs and stuff, it would just provide like a one-to-one kind of interface. It wouldn't provide you with a Rust like way of interacting with those APIs, and it wouldn't provide you with other stuff like, for example, async support or other Rust features. There would be a lot missing there, and so crates like Glue, they handle this for you. They do this work for you. So I was like, okay, I don't know anything about Glue. I still don't know anything about glue, but like, yeah, back then I was like, I don't know anything about glue. Let's have a conversation about this so I can get a better understanding of it. I forgot why I was telling you this, but um, wait, let me open up a new tab. In the new tab, I need to open up Yahtzee because I just realized that I saved this conversation in a different directory. Though the directory, I don't think it's going to matter really. Oh, yeah, there it is. Okay. I need to bring the stuff on the screen so you guys can see it because so far it's just what I'm reading on another machine, and that is not giving you any, visual input or any visual feedback. Right, so NeoVim and open that up. Okay, we are in here. First things first. Okay, so we're going to delete that. We're going to save it. And then we have to go all the way to the bottom and yank all of these lines. And now here, actually here, do we have a free thing? We have this, okay. For now, let's go back here and let's do Gemini explains, what was it, Rust, WASM, Nano, glue.md. Okay, and then paste. Cool. So now we can close this and open it up in Frogmouth so we can read it. Right. So here is our um, conversation. Right. Give me a second here. I need to open up my chat in on my phone. Okay. All right. Cool. Great. So, um, wait. Okay. All right. Done. Where was I? Yeah. So, I started the conversation like this. I said I'm gonna be working on a game dev project in Rust using Nano, Bevy ECS, and a bunch of other crates. I was gonna be doing it using doing it as a standalone, but it then occurred to me that thanks to WASM, I can probably also have a browser build up on itch.io. From what I understand, there's browser APIs for a lot of stuff like, of course, graphics, audio, even game input. That's great. What I was wondering is, how do I go about setting up persistence of any sort when it's a web build? There's no server involved. Whatever is happening is on itch and on the user's machine through their browser, which, from what I understand, is a sandboxed environment. So, what are the options here? So then Gemini mentioned that there's a couple of options here. One is using this API, the local storage API, and I believe this is where Glue came in. Yeah, this is where it came in. How to use it from Rust. You'll use the WebSys crate, which provides raw bindings to all browser APIs. A higher level and more ergonomic option is the glue storage crate. Here's a conceptual example of saving game state, and here it used glue storage. Right. Then it also mentioned this thing, indexed DB API. I might actually look into this as well. I didn't know that this was an option, so we can probably look into this as well. And apparently, this is also available through the WebSys API. Oh, before we continue, I need to ask that question. Okay, so I was planning on, not planning, let's not say I am considering using Rust to build a sort of web app um, that will be running my on my GitHub website on okay, running on one of the pages on my GitHub website. Oh, sorry, zoned out. Okay, that will be running on one of the pages on my GitHub website. I was considering using what do you call it? Using Ratatouille to make a TUI app to run on that page. But now I'm considering using Nano to create a GUI app to run on that page. I'm trying to understand what would be the various layers involved, because from what I understand, the Rust code has to be compiled to a WASM module, which will then run in a WASM runtime, but that runtime is interacting, or is being, I should say, is being executed by a JS environment, which is then talking to the browser API. I need to understand the tech stack involved, and the tech stack involved by understanding the various layers. Okay, I think that's good. So now we can continue reading this. So this is where it mentioned this thing about IndexedDB. I'll probably look into IndexedDB later on. For now, I am interested in the glue storage thing. So then I said, wait, you mentioned glue, and I looked it up. It mentions that it's for building Rust and WASM applications. How come you didn't mention this before when we were discussing web exports of Rust Nano games? What extra does this crate provide that I might be missing out on? Should I be looking into it? Now, when I said this thing about like we were discussing web exports for Rust Nano games, I was talking about a different conversation, but it didn't occur to me that Gemini is not going to understand this because I said you didn't mention this before. So like this Gemini models, like this specific instances context is for this, it's for this conversation, right? So when I say before, it's going to think, before in this conversation, whereas I was talking about before in a different conversation. The reason I'm explaining this is because of how Gemini responded later on. So, Gemini said, You are absolutely right to ask that, and my apologies for not introducing the Glue ecosystem more broadly earlier. My previous answer was narrowly focused on the specific question of persistence. So this is what I'm talking about. Gemini thought that when I said before, I was talking about like earlier in the conversation, but I was actually talking about like a different conversation. So that was actually a mistake on my part. But okay, moving on. You've hit on a key point. Glue isn't just for storage. It's a modular toolkit designed to make writing any kind of Rust WASM application much more pleasant and idiomatic. Let's break down what it provides and why you should definitely look into it. The problem, WebSys is raw and verbose. The foundational crate for web interop is WebSys. It provides raw, direct, one-to-one bindings for every browser API. This is powerful, but it has drawbacks. One, it's not rusty. I like that. It's not rusty. Browser APIs use JS value types, callbacks, and manual memory management for things like event listeners. This can be cumbersome and error-prone in Rust. It's unsafe in the Rust sense. Many WebSys calls require you to manually handle JavaScript's null or undefined values, and casting between JS types can feel unsafe. Then it's verbose. Setting up something simple like an event listener or a fetch request can take a lot of boilerplate code. Okay, I didn't know any of this when I didn't know any of this Wait just a second. Awesome. Thank you for that. Super loud clip. Okay. All right. Actually, I'm curious about something here, so let me just check. Oh, nice. Now, actually, oh well. Right. Like I was saying, what was I saying? Yeah. So it's crazy because like Gemini didn't really mention any of this before in another conversation that we were having about exporting, Rust stuff to WASM, and more specifically doing Rust nano stuff using WASM. But okay, so the solution: Glue is ergonomic and safe. Glue is a collection of higher level crates that wrap WebSys to provide safe, idiomatic, and rusty APIs. Think of it Think of it this way. WebSys is the libc or Win API for the web, providing the low-level bindings. Glue is like Rust's standard library, providing the safe, easy-to-use abstraction on top. What extra does Glue provide? Here are some of its most important components and what they help with. Um, Glue events. So we looked at Glue storage, which gives you access to the storage API. Then we have Glue events. It lets you add event listeners using a safe RAI-based approach. The listener is automatically removed when event listener object goes out of scope, preventing common memory leaks. Then GlueNet provides a clean, future-based API for making HTTP requests. This is essential if you want to load assets from a server or call a web API. Dude, I'm really curious about how well I would be able to set up um, a website with various UI components that interact using Rust. The main challenge for me there would be, okay, there's we have the what was I saying? The main challenge for me there would be actually testing this code out, or rather iteration of testing the code out, because like, okay, think about this, right? You write the code. That code is then supposed to compile to WASM, and then that WASM module gets loaded in JavaScript, and then that interacts with whatever web UI components you have. So you need a proper way to be able to test this out. And it seems like it would be really hectic trying to test something like this out. Or there might be an easier way to there might be no, you know what? There might be an easier way to do this. Yeah, there might be an easier way to do this. Maybe somebody has created, because like, okay, here we are talking about WASM applications, right? Okay, let me open up a new conversation. Gemini has probably given a response here. Right, so it gave a response here about the various layers. Okay. Um, we have a different conversation going on here. Here. Okay, we can open this up. Okay, let me see if that opened up. Yeah, okay, great. I plan on making a static website for static website to host on GitHub pages, since it only allows static websites. But then I got an idea. What if I tried to use WASM in some way to provide dynamicism? Yeah, okay. I don't do web dev in any capacity, so I'm gonna be heavily relying on one of the Rust-based, um, what is it called? Static site generator? Okay, let's just say SSGs, um, to build the site for me. Keeping this in mind, to what extent would I be able to use Rust to create functionality in my web page? I don't mean running, um, actually, I probably shouldn't say that. So we are trying to use WASM because I know this is possible, because the WASM runtime would then be able to interact with other components on the web page, other UI elements on the web page, and so it can do interaction to a certain point and like control things to a certain point. But also something that is equally important is for me to be able to build, test, and iterate. What tools would I be using for this? Is it even possible? So while it generates that response, we can continue reading here. So it provides network-based APIs. We're talking about Glue here. Network-based APIs, timers, um, simple functions like, okay, so this is for writing to the console, and then there's utility functions. What should you be looking into it? Yes, absolutely. While Nano does a fantastic job of abstracting away the core components of a game, that's the render loop, input events within the canvas, drawing, it would not be a web framework. It doesn't and shouldn't have opinions about web specific APIs like storage, HTTP requests, or interacting with the DOM outside of its canvas. This is where Glue fits in perfectly. Your mental model should be: use Nano for all your core logic like graphics, audio, input handling, and the main update loop. When you need to reach out to the browser for a web specific API that Nano doesn't cover, use Glue. So for your project, you'll use Nano for the game itself and Glue for the persistence layer. This is the idiomatic and recommended way to build these kinds of applications. Right. Then I asked this question here, and this is where I think it went into the layers, because I did ask it to explain stuff to me in terms of, I think that came later on. So I'm having trouble understanding how the Rust code is executed in web land or in browser land. I know it gets compiled to WASM. Okay, what did it answer up here? What are these responses? Um, Wait, I'm a bit confused. In another conversation we had about game dev with Nano, Rust and WASM for web, what? We had about game dev with Nano, Rust, and WASM for web game dev builds. You mentioned something about another WASM crate that generates the WASM module along with the glue code and the extra web pages required to run it all. Now glue comes into the mix. I'm confused about which does what, to what extent, and how I'm supposed to be using each. Right, so then there was a response. Of course, this is a very common point of confusion, and it's crucial to understand the distinct role each tool plays. My apologies for not making this clearer from the start. Let's clarify the stack of tools you'll be using. They aren't competing, they work together at different levels of abstraction. The tool you're remembering is WASM Pack. Here's a breakdown of who does what from the lowest level to the highest. The core technology, WASM BindGen. Um, this is the translator and bridge. What it does, this is the fundamental magic. This is the foundational magic. WASM BindGen is a crate and a command line tool that facilitates the high level interaction between Rust and WASM and JavaScript. It lets you export Rust functions so JavaScript can call them easily, import JavaScript functions, classes, and browser APIs so you can call them from Rust. It handles the complex conversion of data types between the two worlds. Example, turning a Rust string into a JavaScript string and vice versa. Analogy. WASM bindgen is the universal. Wait, I've just been reading it. I haven't been understanding this. So WASM bindgen exports Rust functions so JavaScript can call them, and it imports JavaScript functions, classes, and so on, so that Rust can call them, or we can call them from Rust. It handles the complex conversion of data types between the two worlds, turning a Rust string into a JavaScript string and vice versa. All right. Okay, I don't think we need to get an analogy for. Okay, let's read it. WASM bindgen is the universal translator. It allows two parties to speak different languages, Rust WASM and JavaScript, to communicate effectively. WebSys is a giant library of pre-written translations for every browser API built using WASM bindgen. Oh, so that's why I don't use WASM bindgen by itself. What I do use is WebSys in order to call sorry call these APIs. Okay, so this is built using WASM bindgen. The build and packaging tools, the factory foreman or build pipeline. What it does, WASM pack is a command line tool you run to build your project. It orchestrates the entire build process. It calls cargo to compile your Rust code into a WASM file. It then runs WASM bindgen on that WASM file. WASM bindgen reads your code and generates a critical um, glue file, JavaScript glue file. This JS file knows how to properly load, initialize, and talk to your WASM module. WASM pack bundles everything, the .wasm file, the JS glue, TypeScript definitions, and the package.json into a clean, ready-to-use package, usually in a package directory. Okay, all right. Then, ergonomics, the ergonomics library, Glue, the convenience toolkit. What it does, You could use WebSys, the raw WASM bindgen bindings, directly to call browser APIs, but it would be verbose, clunky, and feel very unrusty. Glue provides a set of high-level idiomatic Rust wrappers around the WebSys calls. All right. Instead of manually dealing with JavaScript's JS value type for local storage, Glue Storage gives you a simple local storage set function. Okay, okay. Instead of setting up complex call-based timers, Glue timers give you future-based timers that integrate nicely with async Rust. All right. Okay, what did I ask next? Would I need Glue for other API stuff too, like so and so? That's an excellent and important question. For the most part, the answer is no. You will not need Glue for the core gameplay functionality like in-game audio and input. The reason is that this is precisely the job of a game framework like Nano. Okay, all right. When you compile your Nano application for the web, Nano's internal code automatically switches its backend to use the browser's APIs. All right, great. You write your code against the Nano API, um, and Nano handles the translation to the browser's APIs for you. This is the beauty of the framework. Okay, all right. So, when would you use Glue? You use Glue when you need to pierce the abstraction and um, do something web specific that Nano doesn't and shouldn't know about. Think of the boundary as the edge of your game's canvas. Inside the canvas is Nano's job, and outside the canvas, as in the browser slash HTML page, is Glue's job. Okay, task. Browsing your game scene. Okay, okay, okay. Saving player progress is where Glue comes in. Adding an HTML button outside the Glue canvas that mutes the game. The button is a DOM element Nano doesn't know about. You'd use Glue to attach a listener to that button. Right, so I think this is where Glue would come in if I was trying to make a web-based application or something. Actually, not or something, specifically a web-based application. Wait, give me a second. Sorry, zoned out. Okay, fetching a daily challenge seed from the server, then printing debug info to the browser console. All right, the rule of thumb. Here's the simplest way to think about it. If the feature is something you would expect any game or any platform to have, use Nano. If the feature is something you are only thinking about because this is a web page, then use Glue. Okay. And then I mentioned this thing that I'm having trouble visualizing this thing and understanding, you know, um, this is where I believe this is where the layers came in because there's multiple layers. Yeah, yeah, this is where the layers came in. I didn't read this previously, so this should be interesting to get into. Also, I'm curious about this question that I'd asked. Was it here? Um, okay, excellent question. This is a fantastic way to dip your toes into web development, and you've landed on a very modern and powerful stack. Let's break down your questions. Is it even possible? Yes, absolutely. What you're describing is a very common and effective pattern. GitHub Pages serves static files, HTML, CSS, JavaScript, and importantly, .wasm files. I didn't know that WASM files are also actually, to a certain extent. I kind of knew it. I was assuming that okay, the WASM code gets because the WASM module is being loaded by the 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 JavaScript environment, or runtime. I don't know if it is, or if it would be considered a runtime. But no, I think it would be considered a JS runtime, right? I'm just going to say JS environment. It gets loaded by the JS environment. So I was like, okay, maybe yeah, it does load the WASM. It does include the WASM file as well, because you're not limited in, at least from what I know, your limitation is not the kinds of files that you can put up. Your limitation is that these websites cannot interact with some outside server. Anything that's happening has to happen within that website itself. So any kind of functionality that you're building, it has to be self-contained. It has to be contained within that website itself. It cannot be interacting with an outside server. I could be wrong about that. I need to look into like the specifics surrounding that. Okay, where was I? Yeah, you can use Rust SSG. You can use a Rust SSG to generate the shell of your site. That's the HTML and CSS, and then have the static HTML load your Rust compiled to WASM application, which then runs entirely in the user's browser. This gives you the best of both worlds. The okay, does anybody have, well, I'm gonna Google this. Rust WASM website example. I want to see if there are like specific websites. Is there a list of WebAssembly sites built with Rust? This question was asked 6 years ago. There's there's a website called Seed RS. What is Seed RS? Better yet, there's GitHub, so and so awesome Seed RS. So this one is hosted on GitHub. So it's probably a GitHub site. So let me just open this up. Give me a second here while I check this out. Webpack main features: auto reload, pre-rendering minification, Tailwind CSS, TypeScript. Okay, bundlers: trunk, WASM web application bundler for Rust, then web bundler bundles the seed SP. What is the seed for? What is like what seed are we talking about? A curated list of awesome things related to seed. Seed is an open source Rust framework for creating fast and reliable web apps. Hold on, dude. Okay, so came across another we just came across another thing for building web apps. Also, would web app okay, hold on. Start with the Seed framework. Seed is a front-end Rust framework for creating fast and reliable web apps with an Elm-like architecture. Holy shit, dude. Like, sometimes I'm like, okay, when I'm doing this research, I really wish I would have thought about asking Gemini, hey, are there more options to do other stuff? Or maybe even if I would have thought about Googling it myself, because there are certain things that I come across much later on, and then I'm like, holy shit, I wish I knew about this thing. I wish I knew about this thing. Because I did come across static site generators, but like seed wasn't one of them. I did find three, and then I narrowed it down to one, which I actually might still use because um, I believe seed is not a static site generator. It's a framework that allows you to build web apps. So you might still need to build the you might still need to build the entire, the HTML and CSS and all of that stuff yourself. Or I mean, you might need to use other tools to build it, but like, yeah, I think this is to put things together as opposed to, you know what? Okay, hold up. I think I'll open up another Gemini conversation. Can I do it here? I think we need a new thing here. So scratch stuff, empty directory, Gemini. Uh, let's see what gets mentioned here. Which libraries are being suggested here? So there's WASM pack, then they mentioned trunk. Um, what was the name of that Rust-based thing that I was going to look at? Because that was a static site generator. That's a different thing compared to what Seed is. I'm going to ask Gemini to explain what the difference would be between these two. But first, let me look up Rust site generator. I don't think it was Zola. It wasn't Zola. There was another one. Um, was it Zola? It wasn't Cobalt. I did look at Cobalt and I was super interested in Cobalt. Oh, dude, maybe it was Zola. Yeah, maybe I'm mistaken here. I think it might have been Zola. Zola and Cobalt were two frameworks that I'd come across. There was a third one as well. I remember that. And Cobalt, from what I remember, one of its selling points was its simplicity. Um, but like the simplicity, it was appreciated by a lot of people. It was something that a lot of people were looking for, and there are definitely situations where I would be looking for that kind of simplicity, and if there's anything extra that needs to be implemented, then I can implement it myself. However, Zola provided a couple of other things out of the box that, from the research that I had done between Zola and Cobalt, I learned that, okay, perhaps Cobalt doesn't provide this out of the box. I'm going to have to implement this myself. So I believe it was Zola. I need to, how am I gonna, there might be examples somewhere here, because I remember there were various features that were available within the framework itself. Um, and because of that, like, well, not necessarily because of that, but like there were various features available within the framework itself, but other than that, it didn't necessarily have like a plugin system. It provided you with this, and then you had to work with mainly this, but what it provided you with was a pretty decent set of tools, if I'm remembering right. I don't want to remember wrong and then give the wrong information. Another important thing that I was looking into for, I forgot what the reason was. I was looking for a template engine that will, a template engine that I can use to change to easily generate different aesthetics for the website, because I would much rather deal with this kind of stuff rather than go down to the HTML and CSS level. Not that there's anything wrong with that, it's just that I don't do any of that stuff anymore. So I would much rather stick with this higher level stuff and then use tools to generate all of the lower level stuff. Um, right. I think it might have been Zola. So I want to compare between Zola and Seed, and so I'm going to ask that question. Okay, so I've been doing some research on Rust-based tools that I could use to build a static site to host on GitHub pages. I was set on Zola, but then I just came across something called Seed. Can you tell me more about it, and how would it be different from using Zola? I'm guessing one of the differences is that Zola is a SSG, but I'm not sure what on the the seed side is different when it comes to that. Oh, okay, yeah. In the meantime, holy shit, I didn't even notice this. It was already mentioning Zola in this conversation. That's crazy. Wait, is this the... Yeah, okay. Right. So, um, here's how you'd combine trunk with an SSG like Zola. What does trunk do again? While WASM Pack is a core compiler, Trunk is a workflow tool you will love. It's a build tool and dev server designed specifically for Rust plus WASM. Really? Okay. Instead of a complex manual setup, you just run Trunk serve. I'd mentioned, was it here that I'd mentioned about iteration? Yeah, build, test, and iterate. That's why it's mentioning this. Okay. And I'd also asked what tools would I be using for this? Is it even possible? Okay. Right. So, oh, give me a second. Let me take a sip of my energy drink. And dude, you know what we should do? And I feel like this would work out much better if um I feel like this would work out much better if I was streaming for a longer period of time. But what we could do is every now and then I could take a small break from this, from what I'm doing. And the main point is to not take a break from this exactly, but like to just move my own body mainly, which I'm not sure how what I'm about to suggest is gonna really help accomplish that. But like, yeah, I was gonna suggest that okay, for a short period of time, we can have like a 10-15 minute break or something in which I'll play games on itch, and then after that we can continue with, the research and stuff. Yeah, I don't know. I don't know. Give me a second here. Let me take a sip of my energy drink and also drink some water. Okay. All right. So, let's read from. Oh, sorry. Okay. So, I was reading. I think I should start from here. You know what? Let's go from the beginning. Is it even possible? Yes, absolutely. What you're describing is a very common and effective pattern. GitHub pages serve static files. You can use Rust SSG to generate the shell of your site. You can use a Rust SSG to generate the shell of your site, and then have the static HTML load your Rust compile to WASM application, which runs entirely in the user's browser. This gives you the best of both worlds, the fast, simple, and free hosting of a static site, with the ability to run complex, high-performance logic on the client side. The key concepts: client side versus server side. The important distinction to grasp is that your Rust code won't be running on a server, it will be running inside the user's web browser. What you can do with what you can do with Rust WASM on the client, anything that can be done in the browser's sandbox. This includes DOM manipulation, creating, changing, and deleting HTML elements, handling user events, making API calls to external services. Wait, you can make API calls to external services? Complex. Okay, it didn't mention across the internet, did it? I don't think it did. Complex calculations, rendering graphics to a canvas, and essentially creating a full fledged interactive application. What you cannot do is directly access a database, handle user authentication on a backend, or run any code that needs to be on a trusted server. For that, your WASM application would need to make a network request, that is an API call, to a separate backend service. Okay. All right. So then I'm confused about what it meant by making API calls to external services. Oh, the external service might be the separate service that's running the separate backend service that's where would that separate backend service be running though? Okay, I guess for now maybe it's best if I don't complicate it for myself. Sorry, zoned out. Okay. To what extent can I use Rust to create functionality? The extent is vast. Once your WASM module is loaded, you can. The extent is vast. Once your WASM module is loaded, it can be the entire engine of your page. Here are some concrete examples of what your Rust code could do. Interactive data visualization. Fetch some data from a public API. Why was that so hard to say? Fetch some data from a public API, um, process it in Rust, and use bindings to a JavaScript charting library or even a pure Rust canvas library to render complex interactive graphs. In-browser tools. Create a client-side image filter tool, a markdown editor with a live preview, a complex financial calculator, or even a unit converter. The heavy lifting is done in Rust, which is much faster than JavaScript for CPU-intensive tasks. Small games. You can write the entire logic for a 2D or even a simple 3D game in Rust and have it render to an HTML canvas element. Single page applications. Rust frameworks like Vue and Dioxys allow you to build entire web applications in a component based style similar to React or Vue, but in pure Rust. Your SSG would just generate a single HTML page that loads your Vue or Dioxys application. I should look into both of these, dude. I'd completely forgotten about SPAs. Holy shit. Hold on. Rust, U. I remember coming across this this framework in the past, but then I didn't really go too much deep into it. And then there's Dioxys, which is a full stack app framework. Hold on. Where's the Okay, U is a modern Rust framework for creating multi-threaded front-end web apps with WebAssembly. Features a macro for declaring interactive HTML with Rust expressions. Developers who have experience with JSX and React should feel quite at home when using U. This achieves high performance by minimizing DOM API calls for each page render and by making it easy to offload processing to background web workers. Supports JavaScript interoperability, allowing developers to leverage NPM packages and integrate with existing JavaScript applications. U is not 1.0 yet. Be prepared to do major refactoring due to breaking API changes. Hold on just a second, dude. Okay, that that's a bit risky. That's a bit risky. Though, to be fair, I mean, this would only be a problem if you're constantly updating the framework that you're using. Yeah. Then we have Dioxys, which is a full stack app framework for web, desktop, and mobile. Okay, all right. Dioxys. Like you can just export for mobile as well directly. Build for web, desktop, and mobile, and more with a single code base. Build for so build for so and so with a single code base. Zero config setup, integrated hot reloading, and signals based state management. Add backend functionality with server functions and bundle with our CLI. Dude, you know what? I need to look into this. Dude, I need to look into this. Where was this? Where was this mentioned? Hold on. Yeah, SPAs. So the SPA is going to be, so it's a single page application, right? So the entire thing is within that one page. So that one page, that one application could be developed using, um, what do you call it? What do you call it? That one page could be developed using Dioxys, but then the rest of it could be generated using the SSG. And within the SSG, I could probably provide, maybe I could make some configuration in there to, or I could change some configuration in there to include specific files that I tell it to include. Because obviously it's going to be generating its own files as well, right? Um, but then I could tell it that, okay, in addition to that, add in these specific files as well. And then those specific files could be SPAs. Yeah, I don't know if I'm gonna go deeper into you. That sounds odd, but I don't know if I'm gonna go deeper into the U framework. But I am gonna check out Dioxys because this seems interesting because you can build for web, desktop, and mobile applications. Okay, Dioxys apps. Wait, I just realized I'm not scrolling any of this on my browser here where you guys can see. I'm scrolling on a browser where it's not visible. Anyways, I'll read the thing out. Dioxys apps are styled with HTML and CSS. Use the built-in Tailwind CSS support or load your favorite CSS library. Easily call into native code, Objective-C, JNI, WebSys for a perfect native touch. Truly full stack applications. Dioxys deeply integrates with Axiom or with Axiom to provide full stack capabilities for both clients and servers. Pick from a wide array of built-in batteries like WebSockets, SSE, streaming, file upload, download, server-side rendering, forms, middleware, and hot reload, or go fully custom and integrate your existing Axiom backend. Experimental native render. Render using WebSys, WebView, server-side rendering, live view, or even with our experimental WebGPU-based renderer. Embed Dioxys in Bevy, WebGPU, or even run on embedded Linux. Okay, all right. So I'm really interested in this. So I'm gonna keep this open for now. Let's continue reading these because, like, okay, this whole like web stack thing is becoming interesting because it mentioned SPAs as well, and I'm glad that it mentioned where was it mentioned? It was mentioned somewhere here. Hold on. Um, SPAs using U and Dioxys. Okay, okay. What tools would I be using to build, test, and iterate? This is a crucial part for a smooth workflow. Here's the modern Rust toolchain for this exact purpose. Okay, the core build tool is WASM Pack. This is the essential tool. You run WASM Pack build on your Rust crate and it performs several magic steps. It compiles your Rust code to a WASM file, runs WASM bindgen, which creates the JavaScript glue code needed for JS and WASM to talk to each other, wraps everything up in a nice package directory, that can be easily imported into a JavaScript project or an HTML file. Then trunk, the development and iteration loop. While WASM-Pack is the core compiler, trunk is the workflow tool you will love. It's a build tool and dev server designed specifically for Rust plus WASM. Instead of a complex manual setup, you just run trunk serve. It will automatically compile your Rust to WASM using WASM Pack behind the scenes, then manage your static assets like CSS and images, start a local dev server to host your site, and enable live reloading. When you make changes, your Rust code or when you change your Rust code or a static asset and save the file, trunk automatically recompiles your browser. What? Recompiles and your browser refreshes with the changes instantly. This provides the fast, iterative build, test, iterate loop you're looking for. Oh, sorry, zoned out. This provides the fast, iterative build, test, iterate loop you're looking for. Okay, combining with an SSG like Zola. Here's how you'd combine trunk with an SSG like Zola. Develop your WASM app. You'd work on your interactive Rust component in a separate directory using trunk serve. This keeps things clean. You build your calculator, your chart, or your game in isolation until it works. Build the release artifacts. Once you're ready, you run trunk build release. This creates a dist directory containing your optimized WASM file, the JS glue, and, and an index.html that shows how to load them. Integrate with Zola. Copy the WASM and JS files from the dist directory into your Zola project's static folder. In your Zola HTML template, example so and so, add the script tag that trunk generated in its index.html. This tag will load and run your WASM application. Deploy. Run Zola build. Zola will generate your final public directory, which now contains all the static pages and your WASM application. You can then deploy. Wasn't there another conversation that I had started? What was the conversation here? Okay. Yeah. What was the conversation here? Oh, it was Zola versus C. Of course, you've stumbled upon a fundamental difference in how web applications can be built with Rust. Simply put, Zola is a static site generator, and Seed is a front-end framework for creating WebAssembly applications that run in the browser. Okay, Zola, the traditional static site generator. Think of Zola as being in the same category as Jekyll, Hugo, and or Pelican. Okay, for anyone who doesn't know, I don't know about Hugo, but Jekyll and Pelican are Python-based static site generators, which do pretty much the same thing. Like you provide them, you create these files using templating language, and you also specify the content that's going to be in the files with this templating language, and then the template itself gets applied, and the site gets generated for you. Right, where was I? Yeah, its entire job is to take your content, usually written in Markdown, and your templates, and render them into a finished product of plain HTML, CSS, and JavaScript files. How it works: you run the Zola build command of your development machine you run the Zola build command on your development machine. Zola processes everything and generates a public directory containing the complete, ready to serve website. The result: each page of your site is a separate HTML file. When a user visits when a user visits a page, the web server, like GitHub Pages, just sends the pre-built file directly to their browser. This is best for content-driven websites like blogs, documentation sites, portfolios, and marketing pages. It's extremely fast and SEO friendly by default because the content is already in the HTML. Okay, what is Seed? The Seed is the web application framework. Seed is more like React, Vue, or Svelte, but you write your code in Rust instead of JavaScript. How it works: you write your entire user interface and application logic in Rust. When you build a Seed project, the Rust compiler turns your code into a WebAssembly binary. The result: your web server hosts a minimal index.html file, a small JavaScript loader, and your powerful WASM file. When a user visits your site, their browser downloads the WASM, which then takes over and builds the user interface, manages state, handles all interactivity. This is known as an SPA. Oh, Seed is also used to build SPAs. This is best for highly interactive web applications like dashboards, data visualization tools, complex forms, or even games. It's for when you need to manage. It's for when you need to manage complex state and logic on the client side. Okay, all right. Actually, now this has me curious about Rust Dioxys versus Seed. Actually, I think the answer to that is Dioxys supports web, desktop, and mobile, but I think Seed is specifically for web. Okay, somebody did ask a question on Reddit, though they didn't mention Seed. They mentioned other stuff like Laravel, Django, Ruby on Rails, and ASP.NET. Okay, all the frameworks you list are far more mature and are proven when compared to Dioxys. You don't mention why or what you're building. If this is for fun, use whatever you want. Else, use whatever you're most efficient with. Yeah, that makes sense. Okay, give me a second here. Okay, there was an update in this group last week of a future hot reload feature. 0.7 sounds like it could be a very nice release for Dioxys. Okay. Okay, you know what? Wait, hold on. I think I should ask the question here because I got the answer for this already. Okay. Uh, how, wait. Okay, that seems really interesting. So I can actually describe the entire site UI and functionality using just Rust. Also, um, how does um, seed compare to something like Dioxys or what was it called? U. Do they serve different purposes, or are they just different frameworks for accomplishing the same thing? Um, but they each have their pros and cons. I should rename the stream. I mean, anyways, I did title the stream as I think I'd said Rust and WASM and Nano and Tokyo, which we haven't touched Tokyo at all in this stream, but it's fine. I added the thing in anyways. Yeah, yeah. I guess it's fine. Just a second. Okay. Did we get the response? Um, I'm not sure what's going on here. Okay, all right. Wait, it says Seed is the veteran. No, not Seed. You is the veteran. It says it's a veteran, but if you go to the GitHub page, for some reason it says that, oh yeah, they can be breaking API changes. Okay, anyways, let's see what Gemini has to say. Excellent questions. You're getting to the heart of makes this part of the Rust, what makes this part of the Rust ecosystem so exciting. Can I describe the UI and functionality in just Rust? Yes, this is the core promise. That is the core promise and the primary paradigm. All your application logic, state management, and UI structure, which components to render, with what data, and in what order, are written 100% in Rust. That's what I want to see. That is what I want to hear. Or, well, that's what I'm looking for. That's actually what I'm looking for. Something where I can describe the entire thing completely in Rust. Yeah, yeah, definitely. Definitely. And then I can have like individual single page applications for, certain purposes. Using this, I can have single page applications. So I can have a static I can have a website generated using a static site generator, but then specific pages in that website can be using this. And I guess this answers my question of how those. I don't know if I'd asked that question. Um, Hold on, where is it here? Okay, I think I can ask that question here. Were we done reading this? I don't remember. Yeah, I mean, almost. We were almost done because there was the summary and recommended path and stuff like that. Follow the trunk hello world guide to get a simple Rust and WASM app running locally. This will let you focus on the core new technology without any extra complexity. What all does trunk, sorry, what all does trunk include again? Oh, wait, you know what? Okay, so if I wanted to write my website entirely in Rust, what are my options there? Also, if I wanted to build a simple hello world application that mainly uses Rust and WASM, uh, just to see what that workflow is like. Um, how should I go about doing that? Nothing complicated necessary. Just a simple hello world app, or maybe some simple UI is fine. Okay, right. Um, okay, so this is good news for me. It says that all of the UI is written 100% in Rust. Though, okay, there would be one small complication, which is trying to create connectivity between two pages. I feel like I would be the one responsible for creating that connectivity. A good example is stuff like headers or a sidebar, a side menu kind of thing, a footer as well, if that applies. Because like often there might be things that are common. Like these might be elements that are usually very common amongst a bunch of pages. What was I saying? Yeah. Often these would be elements that would be common in like a bunch of different pages. They would be shared amongst a bunch of different pages. And so anytime you have to make a small change in one of these elements, you then have to go and change it in all of those other pages as well, right? Unless there is something that is, taking care of that functionality for you. So I'm going to need to look into that kind of thing as well, like reusable components, reusable elements across multiple. Um, I'm sure maybe these frameworks handle that. They're probably not that primitive. Did I say entire website? No, I was worried. I was worried it would do this. Rewrite the response, please, but no write actions. I don't want you to build anything for me. I just want the info. Okay. All right. So here I need to decide which of these I would want to use. So I would then be learning two different frameworks. I would be learning SSG and also one of these. I'm going to pick one, Seed, Dioxys, or U. Um, so far, Dioxys is looking promising. Oh, wait, there was a bunch more here to read. However, there are small caveats to the just Rust idea, the HTML host. You still need a single minimal index.html file. This file usually contains nothing more than a head section for the metadata and a body with a single div. A body with a single div. This is the mounting point where your Rust WASM application will. You know what? Something just occurred to me. There would be a difference between the entire UI being generated at runtime by a WASM application versus the entire like web page with its content and all being generated by a tool beforehand. Because if the entire UI and all the content is being generated at runtime or being pulled from somewhere at runtime, that kind of fucks up the SEO because the content is not, you know, part of the web page. It's being pulled or generated at runtime. So I need to keep that in mind as well because there are situations where I would want the content to be present there, and I kind of also want those pages to be um, able to be indexed by Google. Like for example, I have my own my own little knowledge base kind of thing in which I've created entries for various topics. Anytime there's something very specific that I learn that has solved a problem for me, I make an entry for it, just so I have a database of these entries in case I ever need to visit it in the future again. But I also want to post this online. So in case anyone else has a similar issue, then, you know, it can help them out. Okay, yeah. Um, This is the mounting point where your Rust WASM application will attach itself and take control. CSS. Styling is still done with CSS, while you can use Rust libraries that allow you to write your styles in a CSS in Rust format, similar to styled components in the JavaScript world. The final output that the browser understands is standard CSS. Okay, so then that's another thing I need to keep in mind. Also, I should look into this CSS and Rust thing because if that's a thing, then I would be interested in testing that out. I do not mind testing that out and having to learn that kind of framework if need be. So while you still need a basic HTML file and your CSS style sheets, all the dynamic and logical parts of your application, the parts you'd normally write in JavaScript, are handled by Rust. Okay? Then, Seed versus Dioxys versus U. You are correct. There are different frameworks for accomplishing the same thing, each with its own philosophy, pros, and cons. They are direct competitors, all aiming to be the best way to build front end web pages with Rust and WebAssembly. I keep forgetting that WASM is it stands for WebAssembly. I'm so used to calling it WASM. Okay, their biggest differences lie in the architectural patterns they borrow from the JavaScript world. Okay, U's philosophy. U is the most mature and widely used of the three. Its goal is to provide a component based framework that feels very familiar to developers coming from React. It started with an architecture similar to React's original class components and has since added support for functioning components and hooks, mirroring React's own evolution. Um, okay, all right. Then, Seed. Seed is heavily inspired by the Elm architecture. It's more opinionated than U or Dioxys. It enforces a strict one-way data flow model. So we have model, a single struct, holds the entire state of your application, update, a function that takes a message, an event like a button click, and the current model and produces a new model, then view, a function that takes the current model and renders the UI. Okay, the cons here are simple interactions can sometimes require more boilerplate, defining a message, adding a match arm to to the update function than other frameworks. Okay, Dioxys. Philosophy. Dioxys is the newest of the three and was built by learning from others. It is heavily inspired by modern React with a focus on hooks and prioritizes developer experience and raw performance. Its main claim to fame is its extremely fast virtual DOM. All right. Performance often benchmarks as one of the fastest web frameworks, including JavaScript ones, due to its highly optimized virtual DOM. Then multi-platform. This is its killer feature. Yeah. Okay. Wait. Also TUI. You can write Dioxys code that renders not only to the web but also desktop, mobile, and TUI. I didn't know about the TUI part. I should look into that with minimal changes. Okay. Developer experience. The API is clean, modern, and very intuitive for anyone who has used React hooks. All right. Okay. So I think I'm sticking with Dioxys. Okay. All right. So I think I'm going to stick with Dioxys. Hold on. Dioxys. For some reason, I was just fumbling that whole thing. Um, but this has me wondering, would it be a good idea to use something like Dioxys to build the entire website, or would I be better off sticking with something like Zola to generate the website and then use Dioxys for specific situations that actually require WASM? Um, if it's the latter, then I'm wondering that if I wanted to build this, I guess this comes back to um, this, I guess. Oh shit. There's a massive response here. Okay, all right. Did I ask the question here? I don't remember. Hold on. Okay, so if I wanted to write my website entirely in Rust, what are my oh, I did ask the question here. We're talking about both the front end, the code that runs on the user's browser. Okay, back up. Rewrite the response, please. Um, you did fine, but I realized that I forgot to mention a key detail. The website is meant for GitHub pages. GH pages only supports static websites. nothing that can, I want Gemini to correct me on this if I'm wrong, so I'm purposely going to say this. Nothing that can uh, interact with a server or requires code running on a server. Yeah, so then I don't need to ask this next question here. So now we can get the answer. Was there anything more we were reading somewhere? Oh, this is the old conversation. Okay, right. You've hit on a crucial detail that significantly clarifies the possibilities. GitHub pages static only nature um, means we need to adjust our understanding of entirely in Rust for the hosted portion of your website. Key constraints. GitHub pages serves only static files. Okay, it does not execute any server-side code. All right. This means if your website requires dynamic data that isn't pre-generated or needs to interact with the database, that functionality must reside on a separate external server that your client-side WASM application communicates with via. Okay, the external server could be written in Rust, but it wouldn't be hosted on GitHub pages. I didn't know this. So this means that technically you could still, like if it's a GitHub pages website, it could still be interacting with something external. I had no idea. I need to explore this concept a little more. Um, hold on. Okay, so we got a response here, but I also need another Gemini instance. All right, while that loads up, we can read this. Oh, was the response not that long? Well, no, this is, yeah, it's still pretty long. Okay, what was I gonna ask? Oh, yeah. I'm planning on using a Rust-based SSG to build a website to host on GitHub pages. Um, I had read, wait, my understanding of static websites was that the website doesn't make, doesn't interact with an external web server in any way. But after reading another conversation that I had with you, I feel like I might have misunderstood that concept. Is it that um, GitHub Pages doesn't let you host server side code, but the code, no, but your web page could somehow still interact with an external web service of some sort, as long as it's not being hosted on GitHub pages. How does that even work? See, because it's okay, I'm guessing JavaScript might give you, wait, okay, actually, yeah. Um, does is it possible because of JS? Does JS give you options to load things from the internet, um, and send and receive data from external servers slash services? This is how illiterate I am when it comes to web development based, or the web tech stack. Like, I have to ask these kinds of questions because these are the kinds of doubts that I have. Like, unless I ask these questions, I'm not gonna learn. I'm not gonna understand how the whole thing works. Okay, this is an excellent and very pragmatic question. You're thinking like a seasoned web architect, really. Okay. The short answer is yes. For most websites, you are much better off using Zola for the main site and embedding Dioxys apps only where needed. This is often called a hybrid approach and is related to a modern web development concept known as islands architecture. It's an incredibly powerful way to build websites that are both high performance and highly interactive. Here's a breakdown of why this is such a good idea and how it works. The best of both worlds. Okay, so the answer to my question up here was yes. For most websites, you're better off using Zola for the main site and embedding Dioxys. Okay, the best of both worlds. By using Zola as your base and Dioxys for specific features, you get the distinct advantages of both systems without their primary drawbacks. With Zola, what Zola gives you: peak performance and SEO. Zola generates plain HTML. When a user or a search engine hits a page, the content is there the content is there instantly. This results in the fastest possible load times and perfect search engine optimization out of the box. Simplicity for content. Writing a blog post, an about us page, or documentation in Markdown is far simpler and more direct than creating a new UI component in a programming language. Minimal footprint. Users visiting your blog don't need to download a WebAssembly binary. They get a tiny, efficient HTML page. Now, this has me wondering just how big is the WASM download? Like, how much data is going to need to be down? I guess I can profile that somehow. I can, once I figure out exactly what components are involved, and like this WASM, the WASM module is what's being loaded, right? Or the WASM binary. I can then later find out what the size is of this, and also, is there a further step that gets taken where maybe this binary gets read and converted into something, or maybe compressed in some way, or what? Okay. Um, then what Dioxys gives you? The islands. Okay, what was the upper one then? The mainland. Okay. The mainland and the islands. Okay. Rich interactivity. For a feature that needs complex state management, like a real time data dashboard, a fancy calculator, a product customizer, or a small game, Dioxys provides, or a small game, Dioxys provides the full power of Rust and a reactive UI framework. Okay. Then encapsulation. The Dioxys app is a self-contained component. It doesn't interfere with the rest of your static site. The app experience, you can deliver an app-like feel on specific pages without forcing that overhead onto your entire site. How it works in practice. Here's a conceptual guide to implement this hybrid model. So Zola manages the site. Your project would be a Zola project. It handles the main pages. Okay. Create a Dioxys island. You would have to generate a separate Dioxys project. Let's say you build an interactive charting tool with it. Um, then build the Dioxys app. You'd run Dioxys build release. Okay, something I need to look into is how I would create a project that has sub projects. That's important. I need to look into how I would go about doing something like that. Yeah, because here now we're gonna have, and I feel like the perfect example is, what if I had a website that was supposed to be generated using, what is it called, Zola, using Zola. That's going to be one Rust project. And then I have another application that's supposed to be an SPA that's going to be generated with Dioxys, and that's another project. And then I have another application, which is a game that's made using Nano and Glue and a bunch of other WASM stuff. So that's another project. But like, I need all these three to be considered one project while also being separate projects. Is there a way to create like a parent project and these three can be like child projects there? And I can, like, how would the build process work? Are there any things I need to keep in mind? Because I've seen this done before. Bevy, for example, you look at the repo. Within the repo, you have a bunch of these sub projects. So that's how you have what do you call it? Bevy ECS, Bevy, I think Scene, Bevy Audio. I might be getting the names wrong, but like uh, these are all like separate components. So how would I go about setting up a project that has separate components to it? I should ask this question. I should ask this question. Hold on. I need to create a new thing here. I need to make sure I don't load up or overload my, what just happened? Oh, um, right. CD scratch empty. Gemini. Yeah. Open up Gemini. Um, where was I? I forgot which one of these I was reading. Your options for writing a website entirely in Rust. Okay, this spawned another question which took me somewhere else. Was it here? Let's scroll up. Oh, it was here. Okay, it was here. I just had to escape the right. Okay. I want to build a website using Zola. I want to build a website using Zola. Um, I then also, no, within, oh God, dude, we are having lag issues here. How do I, wait, let me type from this other window instead. Okay, so within this website, I want to have two extra pages. One will be um, a data visualization tool I've built using, no, or well, I'm gonna, I'm gonna build using Dioxys, and another will be a game I'm gonna build using Nano. My question is, since these are three separate projects, is there a common Rust way to group the projects together into a single project while also somehow maintaining their separation? Is there a concept of a parent project? How do we even go about that whole situation? How do people create projects that have multiple components within them, where each component is a separate Rust project of its own? Okay, right. So give me a second here, okay? Um, this has been fun, dude. This has actually been this has actually been fun. Um, yeah, you know what? I hope this person's chat is not follower only or anything. Oh, actually, hold on. There's another person here. Oh, this is a person that I was planning on raiding yesterday. Hold on. Co-regulating cozy games after cat playtime. Co-regulating cozy games. Dude, you know what? If their chat is not like follower only, okay, it's verified accounts only. Okay, I guess can't go there then. Um, so there are some that I find some sites that I find streams. There are certain streams that like they catch my attention, but then I open up the stream and it's like verified accounts only chat or follower only chat or like, okay, what is this person doing? It says day 327. Yeah, day 327 Wani Kani. And then day 320 Hanzi Hero. I have no idea what they are doing. It says, man, I wish I could have rated this this cat playing person, the person that's playing with their cats. but like their thing is oh, wait, I think someone is doing coding here. I think so. I'm not sure. Or they're reading something. They're doing some kind of research. Fundraising for Pancreatic Cancer Awareness Month. I don't know if they're currently interacting. I'm not sure. Okay, we're gonna go there. Their name is Mama Lana. I hope they don't have any settings that prevent one viewer raids. We're gonna see. Yeah, okay, I think we're good. Okay, that's gonna be it for today's stream. I'm gonna try and stream again tomorrow. We've got a good streak going, and I'm super happy about that. Like, dude, and today's stream has been fun. Like, we didn't continue learning about the Tokyo runtime, but we did a bunch of research on like web development related stuff, but more importantly, web development related stuff that I can achieve with Rust, specifically with Rust, and also additional stuff like Markdown and HTML and all, but like more importantly with Rust and Rust based tools. So I'm happy about that. Okay, that being said, I hope you guys have a nice day, and I'll see you all next time. Peace.